to this video. In this video, we'll look at some geometric problems that can be solved with three-dimensional vectors. In this first example, we've been given four coordinates in three-dimensional space, and we've been asked to calculate vector A to B, vector B to C. Previous examples, you must remember that vector A to B requires us to take the coordinate of vector OB and subtract from it vector OA, or positional vector A. So that means that we are going to collect those numbers, check them from each other. It's better to represent them in column vectors. So substituting those values and taking them away from each other gives us vector A to B. With the same logic, we calculate vector D to C. Vector D to C means that we have to start from vector OC and subtract OD from it. So that means the positional vector. Therefore, we'll arrange these numbers in column vector notation and subtract them from each other. Now with this vector, -2, -4, and 10. Let's read the next part of the question. We have these two vectors. B of the same problem, we've been asked to show that the line A to B and D to C are parallel, and the fact that DC is in fact twice the length of AB, or vector DC is twice AB. The length is not important at this stage. So, having written those vectors in column notation, we can factorize the 2 out of DC, and what we end up with is the definition of A to B. Well, that's good enough to show that these vectors are multiples of each other. When you read these examples, you should be aware that most of the time, if these four coordinates form a quadrilateral, this quadrilateral will be given to you in either clockwise direction or anti-clockwise direction. So in this case, our quadrilateral is actually a trapezium, because two lengths that are parallel to each other are not the same length. It cannot be a parallelogram. It cannot be a rectangle, and it cannot be a square. The only possible parallelogram that has two parallel sides, the only possible quadrilateral that has two parallel sides is a trapezium. Let's read this next example carefully. We've been given three coordinates, P, Q, and R. We've been told to find the fourth coordinate that makes this shape a parallelogram. So what's special about the parallelogram is that the vector that joins any two vectors, any two adjacent corners, will be the same as the parallel on the other side. So let's pretend that S is missing and S is in this bottom left corner. One way to figure the position of S is to first of all figure out what's the vector QR. If we figure out vector QR, we can add it. QR is pointing downwards in this direction, and this vector is parallel to the vector P to S. Therefore, we can take the position vector P and add QR to it. Adding QR here will take us from P to S. So let's do that. This is one way of figuring that out. So starting with OR and subtracting OQ, we end up with 1, 5, and 7. So then what we are going to take is position vector P, and adding QR to it should end up with the result that we need. We are going to take position vector P, 4, -9, and -3, and add 1, 5, and 7 in that order to each other. The result is 5, -4, and 4. Now, I challenge you to find yet another way to calculate position of S, but not with vector QR. Pause the video and have a go, and I'll show you next. I hope you took that challenge seriously and have had a go at this. Alright, so what you could have come up with is this solution. You could have calculated vector Q to P and take the position vector R and add Q to P to it to get to point S. I'll show you the working out. So position vector R is 8, minus 2 and 0, and working out vector Q to P means that we start with vector O to P and we subtract O to Q from it. 4 minus 7 is simply minus 3. Minus 9 plus 7 is a minus 2, and minus 3 plus 7 is a 4. Taking 8 and subtracting 3 from it will give us 5. Starting with minus 2 and taking away 2 from it will give us minus 4. And starting with 0 and adding 4 to it will give us a positive 4. If you remember correctly, what we found in the previous slide was exactly the same numbers. Example carefully. We've been given that 3i plus 2p, p plus 2 as a coefficient of j plus 120k equals to another vector. So these two vectors are equal to each other. We've been asked to calculate the values of p, q, and r. So right off the bat, we can see that the coefficient of I is simply read to be 3. We don't have to work very hard. P is simply 3. Let's put it down. Then we look at the coefficient of j. Coefficient of j on the right is negative q, and coefficient of j on the left is p plus 2. We already know the value of p, so let's use it. 3 plus 2 is equals to minus q. Therefore q is a negative 5. Coefficient of k is a product of 4 times p times q times r. That means 4 times 3 times minus 5 times r. This coefficient must match the one on the left, so these two numbers must be the same because they're both coefficient of k. 120 must equal to the product of these four values. We already know that 12 times minus 5 is minus 60. Minus 60r is equal to 120. R must be a negative 2. Okay, I'll see you in the next video.